Dear students, under network analysis, previously we have learnt about the critical path method and we have also calculated different types of loads. Now in this video, we will be learning about PERT. So what is PERT? Program Evaluation Review Technique. I have discussed about PERT in the introduction video in detail. You may learn it and understand it better. Now here we shall deal with the problem under PERT analysis. So here we have a question which says that a project consists of the following activities and time estimates. Now here a project is given which has the activities. So activities are listed here and the least time, the greatest time and the most likely time to complete the project are given here. The least time is the optimistic time and it is represented as TO. And the greatest time is the pessimistic time and it is represented as TP. And the most likely time is represented as TM. So this is TO, this is TP and this is TM. Now here we have various questions under this topic. Do not get panicked seeing so many questions. It is very simple. What I have done is, in one single problem, I have consolidated all types of questions that may be asked under PERT analysis. So, here we have the questions. The first question is, draw the network. So, how to draw a network when the activities are given, I have already done in our previous lecture. So I will do it once again here, but you may also see that and understand this more better. The second question is compute the expected duration of each activity. So they are asking us to find the expected duration to complete each activity. It is represented as TE and the formula is TO plus 4TM plus TP the whole divided by 6. So this is the formula that we have to calculate the expected duration of each activity. So you have to remember this formula. The third question is compute the expected variance of each activity. And the formula for that is sigma square, which is equal to TP minus T naught divided by 6 the whole square. So this gives us the expected variance of each activity. For each activity we have to calculate this. And standard deviation is the square root of this. That is, standard deviation is represented as sigma, which is equal to only TP minus T naught by 6. Okay, so this is the standard deviation. For expected standard deviation of each activity we have to calculate by using this formula, and squaring this we will get the variance. And then we have to find, they are asking us to determine the critical path. So we have to find the critical path. So how we will do this? Already I have shown in my previous video how to find the critical path. We have to find the earliest start and latest finish, and whenever the value of E is equal to L, then that event will be included for the critical path, and the activity along those events will give us the critical path, and adding all the expected duration along the critical path gives us the length of the project. And then the next question is compute the expected variance of the critical path. So along the critical path, the activities along the critical path, we have to add all the variances, and that will give us the expected variance of the critical path. In a similar way, if we add all the expected standard deviation along the activities of the critical path, we will be getting the standard deviation of the critical path, which I will explain you while solving the problem. And here we have the last question, which is about the probability. So what is the probability that the project will be completed in 27 days? For this we have to calculate the Z statistic and then we have to evaluate this probability. So I will explain one by one in this video for your better understanding. Now we shall do the first question. Draw the network. So let us draw the network first. So here we have the activities given. So I am going to draw the network now. So let us see that. The first activity that we have is 1, 2, 2. So we shall draw the network for this activity. So the node, that is the event 1 we have here, and from 1 we have the activity emanating from it, that is 1 to 2. So let us draw that. So 1 to 2. The next activity is 1 to 3. So again it is emanating from 1. So 1 2 3. And the next activity is 1 to 4. So I'll draw it here. So 1 to 4. So we have completed these 3 activities. The next activity is 2 to 5. So let us draw that here. So I'm drawing an activity 2 to 5. And then we have the activity 2 to 6. So it's again emanating from 2. So 2 to 6. And then we have the activity 3 to 6. So from 3 we have the activity 3 to 6. And after that we have activity 4 to 7. So it's a new activity. So 4 to 7 I have drawn here. And then we have the activity 5 to 7 and 6 to 7. So with that it's completed. So 5 to 7 and 6 to 7. So this is the network diagram that we obtain for the given activities. So this is how you have to draw the network diagram. So I have drawn it neatly and I have written in a separate paper. So let us follow that now. So if you see here, I have drawn the network diagram clearly. So after drawing the network diagram, we have to draw the table for PERT analysis. That is, the first column is activity. So all the activities I have listed in this column, all the given activities are written here. And then T0 represents, that is TO represents the least time, that is the optimistic time, this column. So I have written this column here. And then TP represents the greatest time, that is the pessimistic time. So I have represented in the next column. And then TM stands for the most likely time. So that is TM. So all these values of TM I have taken in this fourth column. And the next step is we have finished drawing the network. The next question is compute the expected duration of each activity. What is the formula for that? The formula is TE is equal to T0 plus 4TM plus TP divided by 6. So to calculate this, we already have TM. So from the TM, we have to calculate this 4TM. I want to finish the calculation in the tabular column itself. So I have done this 4TM. I have included this 4TM also in the table. If you want, you can do it separately. You can do this separately and you can neglect this column. But I want to finish it in the table itself. So I have done it 4TM here over here. That is, I'm going to multiply all the values of the column TM by 4 and I'm going to write here. So 4 multiplied with 6 gives us 24. 5 4s are 20. 12 multiplied with 4 is 48. 5 multiplied with 4 is 20. 11 multiplied with 4 is 44. 4 6 are 24. 4 9s are 36. 4 4s are 16. And 5 4s are we have 20. So this is the column 4TM. So I have evaluated this column. Now next I have to find the expected time. Okay, so to find this, that is represented as TE. So T is equal to T0 plus 4TM plus TP divided by 6. So what is T0? This column. So if I mark this as column 1, so first column we have to add with, and if I mark this as 2, so we have to add these two columns, and also if I mark this as 3, I have to add 1, 2 and 3 and divide it by 6. So T0 plus TM plus 4TM divided by 6 will give me this column. So let us do that now. So for the activity 1 to 2, let us find the value of TE. It is 3 plus, so 3 plus 15 plus, we have 24 equals 42, and that divided by 6, and the value is 7. So that 7 we have to write here. Now for the next activity, it is 2 plus 14 plus 20 equals 36, and divided by 6 gives us 6. So that 6 we have to write here. Now for the activity 1 to 4, it is 6 plus 30 plus 48 equals 84, and this divided by 6 gives us 14. So we have to write 14 over here. Now for the next activity, here that is 2 to 5, we have 2 plus 8 plus 20 equals 30 divided by 6, and it's 5, so we have to write 5 here. And then for the next activity 2 to 6, we have 5 plus 17 plus 44, which is equal 66, and that one divided by 6 gives us 11. So we have to write 11 over here. The next activity is, here we have 3 to 6, and so for that it is 3 plus 15 plus 6, which is equals 24, and divided by 6 gives us 4. So here we have to write 4. And the next activity is 4 to 7, for which we have 3 plus 27 plus 36 equals 66, and again divided by 6 gives us 11. So we have to write 11 here. In a similar way, for the activity 5 to 7, we have 1 plus 7 plus 16 equals 24, and divided by 6 gives us 4, and so that we have to write here. And finally we have the activity 6 to 7, for which it is 2 plus 8 plus 20 equals 30, and divided by 6 is 5. So that we have to write here. So we have calculated the expected duration of each activity. So if you see here, these are the expected duration of each activity which we have calculated and we have written here. The next is we have to find the standard deviation, for which we have to do TP minus T naught. So 15 minus 3 divided by 6, and that 15 minus 3 divided by 6 gives us the standard deviation. For the variance, we have to square this column and we have to write here. For example, 15 minus 3 is 12. 12 divided by 6 is 2. So that 2 we have to write here. So the 2 I have written here. Then the square of this has to be written over here. So which is the variance. So 2 2s are 4. In a similar way, here we have the next one. TP minus T naught. That is 14 minus 2, which is 12. 12 divided by 6 is again 2. And the square of this is 4, which we have to write here. The next one is 30 minus 6, which is 24 divided by 6. So 24 divided by 6 will give us 4. So we have to write 4 here. And the square of this 4 is 16, which we have to write here. The next is 8 minus 2, which is 6. So 6 divided by 6 will be 1. And the square of 1 is 1 again. The next one we have is 17 minus 5, which is 12. So 12 divided by 6 is 2. And the square of 2 is 4. So that we have to write here. And then 15 minus 3 is again 12. So 2 here. And the square of 2 is 4. And then we have 27 minus 3, which will be 24. So 24 divided by 6 is 4. And the square of 4 is 16. And then we have 7 minus 1, which is 6. So 6 divided by 6 is 1. And the square of 1 is 1. And finally we have 8 minus 2, which is again 6. So 6 by 6 is 1. And 1 square is 1. So therefore we have computed the variance of each activity. So this gives us the variance of each activity, and this gives us the standard deviation. So this gives us the variance and this gives us the standard deviation of each activity, which are the questions here, that is compute the expected variance. So we have completed this. Compute the standard deviation of each activity, that is very important. For each activity we have completed. So we have drawn the network, we have computed the expected duration, which was TE, and then we have computed the expected variance for each activity and the standard deviation for each of the activity. The next step is we have to determine the critical path. And before we go to the critical path, I would like to tell something here. There is a small correction over here, so kindly make it. That is, here we have 3 plus 15 plus 24. The total of these 3 is 42 and divided by 6 will be 7. So this value is 7 here. So kindly make that correction, dear students. So it is 3 plus 15 plus 24 which is 42 divided by 6 is 7. Yes. So after making that, I'm going ahead with the diagram that I have drawn previously. So all the durations I have taken and written here. Now we have to calculate the critical path for all these durations. So for which we have to start with the activity 1, for which we have to calculate the value of E. Always the starting activity, the value of E is 0. And then, so here we have the activity, the event 2. Okay, for the event 1, always it is 0. For the event 2, how many activities are getting into that event? Only 1. So 0 plus 7, which is 7. So this is equal to 7. The next activity is 3. Again, there is only next event is 3, and the number of activities getting into it is only 1. So if the value of E for this will be equal to 0 plus 6, which is equal to 6. And then for this there is only one activity getting in, so the value of E will be equal to 0 plus 14, which is 14. Next we have 5. Only one activity is getting in, so value of E is equals to the previous value of E we have to take, that is 7. So 7 plus 5 we have to do, and so that will be the value of E will be equal to 12. And then for the activity 6, for the event 6, if you see, there are 2 activities getting into the event. So we have to choose the maximum now. The value of E over here is 7. So 7 plus 11 is 18, comma, and then the value of E over here is 6. So 6 plus 7 is 13. So the maximum of these two is 18. So the value of E over here is 18. And then finally we are left out with the activity 7 for the event 7, for which we have 3 activities getting into it. So we have to choose the maximum of 12 plus 4, which is 16, comma, and then here we have the value of E to be 18. So 18 plus 5, so that is 23, comma, here we have the value of E to be 14. So 14 plus 11, which is 25. So we have the 3 values here, and the maximum of these 3 values is E is equals to 25. Yes. Now next we have to calculate the value of L. So the value of L here will be 25 only. Now from here till here, there is only one activity emanating from the node 5. So 25 minus 4 we have to do, and the value of L for this will be equal to 21. And then for the activity 6, the value of L will be equal to 25 minus 5. So 25 minus 5 will be 20. And for the activity 4, the value of L will be equal to 25 minus 11, which is 14. And then we have the activity 3, for which the value of L will be equal to, there is only one activity emanating from the event 3. So the value of L for this event is 20. So we have to do 20 minus 7. And that value will be 13. So the value of L for 3 is 13. And then we have 2. For 2 it is, for example, there are 2, for the event 2, there are 2 activities emanating from it. So we have to calculate the value of L. So one is this, that is L equal to 20. So 20 minus 11 we have to do, and that will be 9. So the value of L will be 9 comma, that is we have to choose the minimum, right? So 9 comma, now here we have an activity, the value of L is 21. So 21 minus 5, which is 16. So the minimum of these two is 9, and so the value of L is equal to 9 over here. And then this activity is, this event is done. Finally we have the event 1, for which there are 3 activities emanating from 1. So we have to calculate 9 minus 7, which will be 2 comma, and then here it is 13. So 13 minus 6, that is 7 comma, and then we have here L is 14. So 14 minus 14 is 0. The minimum of these 3 is 0. So the value of L is equal to 0. So we have calculated the value of earliest occurrence and latest occurrence for all the events. Now we have to check where E is equal to L. So here we have E to be equal to L. Here E is 7 and L is 9, so it's not equal. Here L is 13, E is 6, so it's not equal. Here it is equal, both are 14. And here it is not equal, here it is not equal, and here it is equal. Therefore the critical path will be from 1 to 2, 1 to 4, and from 4 to 7. So this gives us the critical path. So critical path is 1 to 4, 4 to 7. So next we have to calculate the expected project duration along the critical path. So along the critical path, now here the duration is 1 to 4 is 14 plus 4 to 7 is 11. So 14 plus 11 gives us the project duration along the critical path, which is equal to 25 days. The next question is we have to calculate the expected variance of the critical path. So the critical path is 1 to 4 and 4 to 7. So we have it here, that is 1 to 4 this, and we have 4 to 7 this one. And corresponding, if you see, the project duration is 14 and it is 11. So we did 14 plus 11 and we got it to be 25. Now variance is this. So 16 and plus 16. So that we have to add and we have to write here. So the expected variance is 16 plus 16. That is, we have to take the sum of all the variances along the critical path. Okay, sum of all the expected variances of each activity along the critical path we have to take and we have to add. And so that is 16 plus 16, which is equal to 32. The next question is expected standard deviation of the critical path. But for finding the expected standard deviation, we should not add this 4 and 4 because it is the standard deviation of each activity separately. So to find for the critical path, we should not add this. Instead, we have to take the square root of expected variance. So expected standard deviation will be equal to the square root of the expected variance, which is 32. So square root of 32. So the square 32 can be written as 16 times 2. And so the square root of 16 is 4 and this is root 2. So therefore the expected standard deviation is 4 root 2. So kindly remember, to find the expected standard deviation of the critical path, we have to take the square root of the expected variance of the critical path. So if you see in the given question, we have determined the critical path, we have completed this. Expected variance also we have done for the critical path, and the expected standard deviation for the critical path is also done. So all this is completed. The last left out question is, what is the probability that the project will be completed in 27 days? To compute this probability, we have to first calculate, so always remember, we have to first calculate standard normal variate. So we have to first calculate the standard normal variate, which is given by Z is equal to TS minus TE divided by sigma C, where this TS is the time given, that is the specified or scheduled time to complete the project. So what is the specified time? It is given 27. So TS is 27. So this will be equal to 27 minus TE. TE is the expected duration that we have calculated here. What was that expected project duration? This is TE. That is 25 days. So TS minus TE, which is 27 minus 25, divided by the expected standard deviation that we have calculated here. So what is the expected standard deviation that we have calculated? It is 4 square root of 2. So that we have to substitute here. So 4 square root of 2. So that will be equal to, what is 27 minus 25? It is 2 divided by 4 square root of 2. Now here we can calculate it separately. So if you see here, we can write it as z to be equal to, now if you see here, we have in the denominator 4 square root of 2. So I'll just show that here. First we will find square root of 2, which is equals this value, and this has to be multiplied with 4, and we get the value to be 5. We will take up to 3 decimal places. So 5.656. So in the numerator we have 2 divided by, in the denominator we have 5.656. Now 2 we have to further calculate this. So 2 divided by 5 point, we have 656. So it is 2 divided by 5.656, which is equals 0.3536. So I can take it as 0.35, just to 2 decimal places. So that is equal to 0.35. So the value of Z is equal to 0.35. So the required question is, we have to find the probability that the project will be completed in 27 days. That is, we have to find the probability that the project will be completed in 27 days, which means either it should be 27 or lesser than 27. So T is to be lesser than or equal to 27. So this is what we have to find, which is same as the probability of the Z statistic, that is the standard normal variate, lesser than or equal to, what is the value that we have evaluated? 0.35. So that we have to write. So 0.35. Now this has to be calculated from the normal table. So let us take the standard normal variate table, and we will evaluate probability of Z lesser than or equal to 0.35. So let me tell you how to do that. So we have to do it for 0.35. So we should take first 0.3 on the Z table. That is, here we have the Z table. So if you see here we have 0.3. Along with that, if we add 0.05, we will be getting 0.35, right? So 0.3. So under 0.05 we have to see. So under 0.05 we have here, that is 0.6368. So this is the solution. So we have 0.6368. So therefore this is equal to 0.6368. And we have to give this answer in percentage. So we have to multiply the 0.6368 by 100. And so we will be getting it as 63.68%. We can also simplify it and we can make it to 1 decimal. So 63.7%. I have rounded this. So this is the probability that the project will be completed in 27 days. So this is the probability. So we have completed all the subdivisions of this question. So hope you have understood the complete PERT analysis. So how to find? So as per the required question, you form the table. So whatever is asked here, according to that you form the table and you complete it. So hope you have understood the PERT analysis. Thank you.